Whatever you do to a reaction at equilibrium, it will try to undo if it can. How does that apply to what we were just talking about? I'm throwing in a bunch more hydroniums here, right? By adding an acid, I'm making more hydroniums. So I'm making a change. I'm adding more hydroniums. Can this reaction get rid of hydroniums? By going more in the backwards direction, using up hydroxides. Yeah? So this reaction will try to undo what I did. I threw in more hydroniums. It'll try to undo it. How can it do that? By using up the hydroniums, going more in the backwards direction, using up hydroxides in the process. Now, Le Chatelier's principle describes what happens. We'll worry later about why Le Chatelier's principle does what it does. We'll examine rates in some detail. We'll be spending a chapter talking about reaction rates and how they happen. But for the time being, Le Chatelier's principle is a way of explaining what happens to the concentrations of these things if I change one of them. So for instance, we're back to pure water again. And I open up the bottle and I throw in some sodium hydroxide. Now sodium hydroxide dissolves and separates into sodium and hydroxide ions, right? So adding sodium hydroxide would increase the hydroxide concentration. What would that do to the hydronium concentration? It can go down, right? They're on a seesaw. We have a mathematical expression that we're going to use that, that quantifies this. Concentration in moles per liter of hydronium ions times the concentration in moles per liter of hydroxide ions is always equal to 1 times 10 to the negative 14. What is the relationship then in this equation between these two quantities? Inversely proportional. If one goes up, the other goes down. Remember when we did this? If one gets bigger, the other has to get smaller if this remains constant, right? And this is a constant. So if one of these gets bigger, the other gets smaller. This is a mathematical way of expressing that same relationship that Le Chatelier tells us about and that we just talked about. Remember, in pure water, each of these has a concentration of 1 times 10 to the negative 7 moles per liter. And of course, the product of the two would be 10 to the negative 14. If I increase this to 10 to the negative 5, that's an increase, isn't it? Okay? Then this would have to decrease to 10 to the negative 9, wouldn't it? Right? One goes up, the other goes down. We okay? If this increased to 10 to the negative 2, this would have to decrease to 10 to the negative 12. Now, it's nice and easy when we keep these ones, isn't it? That we're just looking at the exponents. You know you add exponents when you multiply. But if this increased to, if this increased to 2.3 times 10 to the negative 2, could you figure out what this was? If this was 2.3 times 10 to the negative 2 moles per liter, what would that have to be? Do it. Get a little exercise with your calculator. You might not have used scientific notation in a while. I'll remind you again, since you don't use scientific notation very often, right, in your math classes, for instance, that the key that you use is either marked EE or EXP. In some rare cases, it's marked like this. Something like that. But do not use that key. Do not enter into your calculator 4.3, enter multiplication, and then use this key. Sometimes it works, sometimes it doesn't. You need to go into the reasons why.
Will you be able to explain it?
Yes. So the EE key, your calculators all have a key called EE or EXP, don't they? That's how you enter scientific notation. Okay? And you're going to get some practice dealing with it. Just make sure you're on top of it. Strongly recommend that you bring a calculator you're familiar with when it comes time to take the test.
Can you tell me exactly what you pressed?
Yes?
Yeah.
Ready?
Yeah.
You'd enter 1. You got an EE or an EXP?
I got an EE.
1, EE, negative 14,
Gotcha.
divided by
Divided by.
2.3, EE, negative 2, equals.
I thought we had to press like the log stuff to do that stuff.
Now, to get a little practice, what's the pH of this solution? What are we going to do to that number? Take the log and change the sign.
Let's see.
Wait, if you take the log.
Take the log. Press log.
Good sound geometry. Sammy.
I'm still in geometry, so like it's hurtful on my career.
Here's the thing. How do you take the logarithm of that number? If you got that number in your calculator, you're going to use the key that says LOG. Now, depending on your calculator, you may have to write the number down. If you're not real familiar with your calculator, press the log key and then put that number back in. Many calculators will just take the log of whatever's on the screen when you hit the log key. Others, that's not what they do. This one is different, for instance. What was the logarithm of that number? Negative 12.4. So the pH would be 12.4. I will caution you, when the concentration is more than 1, when the concentration of hydrogen ion is more than 1, the logarithm is positive, so the pH is negative. And we can have negative pHs. Be careful with that.
Wait, how do you have negative pHs exactly?
We can have negative pHs.
What would that
Any
imply?
concentration, well, first of all, the logarithm of 1 is
Is that one? I mean 0, sorry.
0. 10 to the 0 power is 1, right? So the logarithm of 1, if you had a 1 molar solution of hydronium ion, its pH would be 0. So if you had a 10 molar solution of hydronium ion, the logarithm would be 1 and the pH would be negative 1.
And change the sign to pH. So it's
Where does the scale go from?
Doesn't really go much lower than negative 1. It doesn't really go much higher than 15.
So what does it mean? What does it mean for a pH to be negative 1? Does that just mean that it's
It
really
means it's
basic?
really, it has a high concentration of hydronium ion.
You don't want it on your skin.
Right?
Visually, like, when you measure the pH of that, of this, what exactly, like, were we getting the pH of a solution of water?
So in my example here, I added hydroxide ions. How would I add hydroxide ions? Adding sodium hydroxide, lithium hydroxide, potassium hydroxide.